Okay, number one, it is review day. 11 and 19. 19 is Sky and Zoe's birthday. Happy birthday.
We are.
So, cosine, x value, right? X value. So 5 pi 6 is here. X value is negative square root of 3 over 2. Boom, right? Got it. Okay. Secant is 1 over the x value. So I go to 5 pi thirds, which is here. And I want 1 over the x value, which is 1 over 1/2. But that just flips anything, 1 over a fraction just flips it up, and I get 2 over 1. Boom. Sine is the y value. If I need negative 3 pi fourths, okay, well, if positive 3 pi fourths is this rotation forward on my tire, then a negative 3 pi fourths is like going backwards the same distance, which puts me right here to 5 pi fourths. Okay, that's where I want to be. If I want the sine value, it's the y, which is a negative square root of 3 over 2. Okay, tangent, pi halves. Well, here's pi halves. Tangent is really going to be the y over the x, but if I go 1 divided by 0, that's going to be undefined right there. So I'm going to go undefined. If you use the empty set, I'm okay with that, but technically the answer is really undefined. Yeah, undefined. Okay. How am I doing?
Great.
Okay, now this says find the angle, okay, and I want it in terms of pi, so I want radians. So I'm looking for an angle. So sine is the y value, so I'm looking for a y value of negative square root of 3 over 2. But I want the closest, right, Zoe? I want the closest. So if I go to negative 3 pi over 2 for a y value, it's right there. Now, do I really want to go all the way to 300 degrees? Do I want to run 300 yards? Or Zoe, do I want to go backwards 60 yards?
Backwards.
A lot shorter, right? So that's the same thing as a negative pi thirds as far as radians, okay? Negative. So theta is equal to negative pi thirds. Got it? Tangent is 0. So tangent is going to be, here's all my tangent values. Tangent 0 is here. It's also here. But do I want to just sit on the mats at track practice, or do I want to run a 180? I'd rather just sit on the mats, right, and chill the shortest distance. So it's 0. So theta is equal to 0 radians. Okay. Cosine negative 1/2 is an x value. This is my x value. So I'm looking for negative 1/2 for x value, which is here at 2 pi thirds, or all the way over here at 4 pi thirds, but which was closer? 2 pi thirds, right? So theta is 2 pi thirds, okay? Tangent, inverse is square root of 3, okay? So I have my tangent values on my unit circle. It's right here. It's also way over here, but I want to run the shortest distance. Yeah. What? Am I missing something?
Somebody.
Oh, yeah. Well, I did this past, yeah. Pi thirds. Yes, Landon. Thank you. Okay, now, sine inverse of negative 3. So we're going to have to use a calculator, but I just did 8.
Couldn't see it.
Oh, sorry, my bad. Yeah, square root of 3 is right here for tangent, right? The angle is pi thirds. Okay. Now, sine, number 9 can't be done. You tell me, why can 9 not be done?
Because the circle only goes to -1.
Totally right. If you want a y value of negative 3, the furthest end you get is -1. You can't do it, right? And you can try it on your calculator, but you'll get an undefined, so it does not work. None. Undefined. Thanks, Mikaiwa. Now, 10. Find all angles. So this time we're going to look for more than one. There's going to be 2 answers, because between 0 and 2 pi. So negative 1/2 for cosine is here at 2 pi thirds, and it's also here. So this one we want both answers. It makes sense we want both answers, because it says all answers between 0 and 2 pi. So there's 2 answers. You're going to take the 2 pi thirds, and you're going to take the 4 pi thirds. Both of them have negative 1/2 at the x value. So I'm going to take both answers. So I'm going to say 2 pi thirds and 4 pi thirds, okay? I want both answers. Make sense? So tomorrow if it says between 0 and 2 pi, you can look for the answer on the unit circle. So if it happens twice, give me both, okay? All right, 11. Well, let's see. I think the easiest way to do for me is to start here. I'm just going to highlight it so you can see it. So my roller coaster ride is going to start down here. I'm going to call it a negative cosine. There are 4 correct ways to do this. There really are. We could call it a sine and start here. We could call it a cosine and start here. We could call it a negative sine and call it here. All 4 of those would be correct. I like to find the easiest. So for me, the easiest is to start here on my roller coaster and then go up and down and call it a negative cosine. Okay, and I've got the 2 up here. I've got the sine and the cosine. So I'm going to use this shape but upside down. Okay. So I'm going to go straight to calling it a y equals a negative cosine, right? Now the amplitude seems like it's going to have, yeah, it looks like it's going to have an amplitude between, so my amplitude's going to be 4 minus a minus 1 over 2. Max minus min divided by 2. So it's max, it's your maximum, I'm sorry you guys, it's your maximum minus your minimum divided by 2 will always give you your amplitude, always. Okay, so if you can't find the midline, if you can find the midline, it's easier, right? Yeah. So the midline is in there. So in this case, it's going to be 5 over 2, 5 halves, or 2 and a half. So that means if I do find the midline, which I think is here, let me draw the midline in, okay? If you can't find the midline, it's okay. Some kids can't.
The answer is 5.
Yep, that's the amplitude, or 2 and a half. And I'm going to change it to 2.5, okay? And I'm going to show you, Landon, so you can see the visual, okay? If you can find your midline, okay? If you can find your midline, which I did, it's going to be up 2 and a half, down 2 and a half. You guys see that? That's my amplitude. If you can find your midline, up 2 and a half, down 2 and a half, that's my amplitude. Now, if you can't see it, then we've got a little formula. To find the amplitude, it's just the maximum minus minimum divided by 2, and that will always work, okay? Always, if you can't find the amplitude, okay? Now, I need to find the frequency. I got to find B. So the frequency B is 2 pi, always 2 pi, divided by the curve width. So if I took my roller coaster ride, and I went from 0 to pi, that's the width, right? So it's 2 pi divided by the width. Sorry, you guys, I know I zoomed in too much, didn't I? So it's 2 pi divided by the width, which is 2 pi, and the width is, if I take one roller coaster ride, the width of this curve is pi, right? So my frequency is 2, which makes sense because I got 1, 2 curves. So my 2 here. Now, is there any horizontal shift? No, because I started my curve right on the y-axis. I didn't get bumped over or back at all. It starts right there on the y-axis, okay? So then I'm going to go just x and no inside movement, right? It would be the opposite of the inside. Now, it got bumped up. Well, I found my midline, so it got bumped up 1.5. So I'm going to go plus 1.5. But if you can't figure that out, then to find the value d, call that d, it's going to just simply be your minimum. Scoot over, it's your minimum plus your amplitude. Will always give you your midline. Okay, that's always going to give you your midline. So our minimum was -1, and our amplitude was 2.5, which means our midline's at 1.5. Okay, so these are little formulas that can always help you if you get stuck. Okay, B is 2 pi divided by the width. That's the frequency. The amplitude's maximum min divided by 2. My midline can be found by the minimum plus the amplitude. Thumbs up? Easy little notes. Make sure you have those, okay? Okay, 12. Let's graph this, okay? So let me get a piece of graph paper out. And I'm going to try to do a beautiful job graphing this. Look at that, Zoe. The sunshine's coming out for you and Sky's birthday. Isn't that nice?
Wow.
I know. Okay, here's what we're going to do. All right, let's graph this. And we're going to go from 2 to -2 because that's my amplitude, right? So the amplitude is the absolute value of negative 2, which is 2. Amplitude is always positive. So my amplitude is positive 2. Even though that's a negative, the negative just makes the sine curve upside down, right? The vertical shift is up 2, okay? The vertical shift is up 2, and that's from that number there. Now the period, if the frequency is 4, then the period is 2 pi divided by 4. Okay, so it's just 2 pi divided by the frequency, which is 4. So that means the period is pi over 2, if I reduce that. So this is what I know. Each curve is going to be this wide. That's going to be the width. It's my period. That's my width. Okay? It's going to go up to 2, down to 2. Okay? And it's going to be upside down. So I'm going to do it in 2 steps. First thing I'm going to do is I'm going to graph upside down sine. So the first thing I'm going to do is I'm going to graph this shape from 2 to negative 2. I'm going to do that first. And I'm going to do the shape within pi halves. Okay? Okay. Happy birthday. I forgot it was your birthday.
I know. I was waiting and you didn't even say happy birthday.
I know.
Kind of broke my heart a little bit. So.
Come back! Okay, come on. Happy birthday to you. Do you want a Smarty? Happy birthday to you. Happy birthday, dear Julia. And Zoe Scott, happy birthday to you. Ah, thank you, Julia.
So pretty.
I know, I can't sing. So let me go. So I'm going to go pi halves, pi, 3 pi halves, 2 pi. And I like to go 4 squares. I like to go 4 squares because there's really 4 parts to my graph, right? There's the x-intercepts, the zeros. So there's the top and the bottom. There's the max and the min and the start and the end, right? So I want this shape to be here. So here, 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 here. So I did a dot to dot. So I want this shape here. So I did a dot to dot. There, 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 and there. So I did my dot. I did this point, this point, this point, this point, and this point. Okay, and so I can make one curve. I need 3 more because my frequency is 4. So I'll do a dot to dot again. I'll go here, 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 here. There's a second curve.
Wait, how come it's not in the middle?
Let's do it again. Okay, let's just do it between here and here. Okay, it's got to be this shape. So it starts at 0. Watch Zoe, and it ends at 0. Halfway through, it's at 0. See how I'm doing this? It's down at negative 2, and then it's up at positive 2. See how I do my dot to dot? And then just sketch it in again. We'll do that one more time, right? Take this shape and put it right here. Starts at 0, ends at 0. In the middle, it's at 0. Here, at a fourth of the way, it's down at 2. 3/4 of the way, it's up at negative 2. And then I just sketch it in. Okay, now, believe it or not, I have 1, 2, 3, 4 of these, which I should have. Okay, now, the last thing we're going to do is move it up. The last thing we're going to do is we're going to then do my vertical shift. We're going to go up 2. So every important point, I just move up 2. So this point goes up to here, moving everything up to value of 2, value of 2, value of 2, value of 2. Just moving the entire, you should take the entire graph and shift it up 2 points so that it sits up here, and it's going to look like this. There it is.
Wait,
Yeah.
Would you do like cosine on the test, or would you do like tan?
I don't know. You gotta wait and see. Probably a cosine. Okay, guys, got that? Okay, I'll wait for you.
We just move it up just one.
Moved up 2.
Oh, two.
How come? Because of that 2 right there, Sky. Okay, and we'll do 13 in a second when you're ready, okay? Okay, ready for 13?
Go ahead.
Now you guys get to use your notes, right? You're going to use your notes. So to do 13, cotangent. What does cotangent look like? Well, if I use my notebook and I go through my notebook, cotangent, if you look it up, looks like this. So cotangent curve looks like this. Pi halves, and a cotangent curve looks like asymptote, and a cotangent curve looks like this. This is a cotangent curve, okay? That is a standard cotangent of x, okay? What we want to do then is take our cotangent and we're going to make it upside down. It's going to be upside down. We're going to stretch it by 2. I'm going to stretch. And then we're going to move it to the right. So we're going to shift to the right pi 8ths. Okay? So let me do that. Right, so step by step, first let me just real lightly sketch in the original cotangent. I'm just going to put that one in first so I can see it. And then I'll move things around. Okay, so I'm just going to graph regular cotangent first. Can you guys see this?
Yeah.
Okay, good. So we're going to go pi halves, pi, right? Standard curve is going to look like this, and I'm going to move it, okay? Asymptote here, okay? The cotangent at 1, -1 looks like this, okay? There it is. That's what's in your notes. That exact graph is in your notes. Now, let's change it, okay? I'm going to make it upside down. I'm going to take this graph, and I'm going to make it upside down because of the negative. So I'm going to flip it. And then I'm going to make it go twice as tall. To make it twice as tall instead of going to 1, I'm going to stretch this out to 2. I'll say it again. To make it twice as tall, to stretch it, instead of hitting here at 1, I'm going to go up to 2. To stretch it, instead of going here to -1, I'm going to stretch it down to -2. Okay, so it's going to look like this. Let me first flip it and stretch it. So first I'm going to flip it and stretch it. Okay, do you see how I flipped it and stretched it? Because I'm going to erase the original here in a second, okay? Ready to see how I flipped it and I stretched it. So it's twice as tall, it's upside down. And I'm going to erase the original here in a second because it's kind of in my way. All right? So if I can find the eraser, it's going to work for me. Let's see if I have one. Oh, of course not. I don't have an eraser. Okay, so I flipped it and I stretched. Okay, so now I'm going to erase the original. That's not there anymore. And now the last thing I'm going to do is I'm going to move it pi h to the right. So if this is pi fourths, because half of pi halves, then 1 square is pi eighths. So I'm going to take everything, including the asymptotes, and move everything over pi eighths. And the graph itself, the curve is going to go here, there, and there. Because I had to do one last thing. I had to do this. Hold on. I had to do this, Lana, right here. See where my pin is?
Yeah.
I had to do a shift, right? So I did a horizontal shift. How much did I shift it?
Pi.
So I took the whole curve and bumped it.
So the asymptote comes over to pi 8?
Yes, everything. So take the whole graph, pick it up, take the whole graph, pick it up, and move it over pi eighths. right? That's all I did. Bumped it over. Okay, thumbs up?
Wait.
I will. Okay, all right. Zoe, you okay?
Yeah.
Yeah. All right. Nah, okay. Okay, 14, the tide problem, right? So let me get a piece of graph paper out here.
What were the vertical asymptotes?
At pi 8s, oh, do I ask that? Yeah.
Yeah.
So they're at pi 8s and at,
Pi.
okay, pi plus an eighth, okay?
9 pi 8s?
Pi, smart guy.
9.
Because he got, pi is the same, so 8 eighths. You okay with 8 eighths? You okay with 8 eighths?
8 pi 8?
8 eighths is pi. You okay with that? And then I add a 1/8 pi, and I get a total of, see how Sky did that in his head? 9 pi. Nice job, Sky. Yeah. You know your fractions, don't you? Like it. Okay, now let's do the tide problem. So, okay, first thing I'm going to do is just start right away with 24-hour day, right? I'm going to start with a 24-hour day. And I'm going to go and 1 a.m. So let's make this midnight. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's noon. 13, 14, 15, 16, 17, 18. That's 6 p.m. 19, 20, 21, 22, 23, 24. There's midnight again. Okay? Next day, midnight, okay? How am I doing? I'll wait for you. Got a height of 5, 18, 6 p.m., yeah.
No, but what's after that? 23. Well, 24.
24.
Thank you.
1, 2, 3, 4, 5. 1, 2, 1, 2, negative 2. Okay. And today I'm going to change these numbers into decimals right off the bat because it's so much easier if you change them to decimals right off the bat, okay? So we got a height at 1 o'clock of 5. So I'm going to put my first point here. Boom, right? Yep. Yep, and down. Thank you. Now this number is going to be 8.75 because 45 minutes is 3/4 of an hour, right? 45 minutes is 3/4 of an hour. Now if you can't do that, just divide. What is 45 out of 60? 0.75. Okay, if you have a difficult time with that, just divide 45 by 60, 60 minutes an hour, 0.75, okay? So now that means my low tide's at 8.75, 6, 7, 8.75, and a high low tide of 0.2, okay? Now, what I'd like to know,
They can't see.
oh, I'm sorry, you guys. Yeah, I got it too far zoomed in. Thank you. So what I'd like to know is what is the time or the length from high tide to low tide? What is that actual time? So what is the time from here to here? Yeah. 1 o'clock minus 8.75. So the time is 7 hours. So this time is 7 hours and 45 minutes, right? That's the length from high tide to low tide. So if I want to find the next high tide, right, I'm going to take my 1 o'clock, okay, take my 1 o'clock, and I'm going to add twice this, right, to get my next high tide. So if I take 7.45 plus 7.45, I get a 15.5 or 15 and a half hours. Okay, I don't want to confuse you, but it's 7.745 and another 745 puts me at 15.5, which is 330 plus a 15.5, 6.
But you were doing it in decimals.
Yeah.
But
Oh, guys, I'm sorry. I zoomed it in too much, and the hard part is once it starts
Well, are we
recording, I
missing
can't zoom.
anybody today? we missing anybody?
Emma.
Emma.
Oh, yeah.
Okay, so for 1 o'clock. So one full tide is 15 hours and a half. Okay, one full tide. From high tide to high tide is 15 hours and 30 minutes, okay? So that means my next high tide is 16.5 because 1 o'clock.
Sorry.
Yeah.
7.45 plus 7.45 is what?
15 and a half.
15. It is?
Yes?
Well, I'm sorry,
It's
Landon.
in decimals.
It's in decimals.
7.75. It's not 7.5.
Thank you,
Can you
Micaiah.
just like stick to decimals then?
Yeah. So 7.75 plus 7.75 makes 15.5. I did mess up, Landon. No wonder you're confused. I'm sorry. Makes it 15.5, which is 15 hours and 30 minutes, okay? 15 hours and 30 minutes, right? At 1 o'clock, high tide, let's go 15 and a half hours more to get to the next high tide, which puts us at 16.5, which is really 4:30 p.m. Does that confuse you, 4:30 p.m.?
1 o'clock could also just be 1.
Right.
Okay.
So if I go to 16.5, 12, 13, 14, 15, 16.5, next high tide is right there. Okay, so we go ahead and graph it in.
Wait, we got 15 or
16, because we have to start at 1. Okay, let me back up so you can see it, okay? So from 1 o'clock, and if I add a full tide, from 1 o'clock, if I add a full tide, puts me at 6:30. Okay, so from 1 o'clock, if I take 1 o'clock, and if I add in my 15.5, it puts me to 16.5 is my next high tide, okay?
Wait. Where is waiting?
Okay, so here's 1 o'clock, right? Zoe, you ready? Here's 1 o'clock.
Yes.
So for 1 o'clock, if I add 7.75, I get half tide. And if I add another 7.75, I get 7.75. I get another half tide, which puts
Wait, so really just add 7.75 from 8 or 7.75?
from 8.75. Yeah.
And then you don't have to add the extra.
No. Yeah. Okay, now let's get an equation.
It's just I didn't.
Let's get an equation. So the equation, let's start right here. Y equals, let's call it cosine, right? Start with y equals cosine, right? Bye, Sky.
Have a great day.
Huh? We're going to get that as soon as we end up getting our equation. Looks like it's about 0, right? Okay, so let's get an equation. Y equals cosine. You guys agree with cosine?
Sure. It's like
Okay. Now the amplitude, max minus the min divided by 2, right? Amplitude, max minus min divided by 2, which the amplitude then is going to be 5 minus a minus 2 over 2, which is 7 over 2 or 3.5. So my tide goes up 3.5, down 3.5. So here's my equation. Starting to form my equation right now. Y equals 3.5 cosine. Now we also need to know the frequency. So B is 2 pi divided by the curve width. Well, that's where we got to go back to the tide, okay? What is the length of one high tide to high tide? What's the length in terms of time? How long does it take to go from high tide to high tide? How long does it take to go from high tide to high tide? 15 and a half, right? Does that make sense? So divided by the 15.5. So if you want to make yourself a note, this is the time of a full tide. Okay, that's time. That's the time of a full tide, right? So I'm going to put that here. 2 pi divided by 15.5. Okay? Now, I do have a horizontal shift because I started at 1. Didn't start at midnight, right? So it got bumped over 1. So I'm going to have a parentheses x plus, minus 1. And then the whole curve, the midline, is somewhere in here somewhere. I think, yeah, it sounds like somewhere in here, the midline. So if you're not sure how to get the midline, we can take our minimum plus our amplitude to get our midline, okay? So our midline is going to be at minimum is -2 plus our amplitude, which is 3.5, which makes a 1.5. Boom, there's my equation. Highlight that. Highlight that, okay? All right, now, what's the height at noon? Sure looks like the height at noon is about 0. You guys agree? But we can get exactly what it is, and I'll show you how. Here's how I'm going to do it, okay? To make it easier on my calculator, and I don't want to confuse you, but to make it easier to plug this in my calculator, I'm going to figure out what that number is, okay? What is 2 pi? I don't know.
I got it. It's 0.405.
Yeah. Yeah. So that number is a decimal equivalent to that. So to make it easy, I'm going to go. You ready? Watch me put it in my calculator. I'm going to go. Let's see if I can scoot in so you guys can see this. Come on. We're going to get new screens someday. I'm going to go clear. I'm going to go. You ready? 3.5 cosine. Oh, am I right mode? Oh, yeah, good. 3.5 cosine of 12. I'm going to put 12 in because that's my... Oh, let me back up. I need my number. I need my... Hold on. What was it again, Jaden?
0.405.
Parentheses 12 minus 1, because I plugged in my 12 right there, right? Double parentheses plus 1.5, and I get an answer about 0.61.
Oh, wait a minute. So we're not graphing it.
No, I didn't graph it. I just plugged it in. You could. You could. Do you want to graph it?
I mean, no, that's okay.
So about 0.61 meters.
I got my graphing.
About 0.61 meters, okay? When is the next high tide? We know that. That's going to be at 4:30 p.m., right? And we figured that out earlier, right? Okay, now, if a sailboat has a 3-foot keel, was moored at the pier, what are the times in a 24-hour period the boat should not be in the pier? So let's graph it this time, okay, Zoe? Let's graph it. So to graph it, let's use some common sense, okay? So to use some common sense, my window. Let's go 0 to 24, right? Oh man, we're gonna get new projectors someday. Scales. Let's go from negative. I'm gonna go from -3 to 6 will work. Y equals clear. We're gonna go 3.5 cosine. What was that number again, Jaden? It was point what?
0.405.
0.05. It's easier than typing 2 pi divided by. Parentheses x.
What's the
Subtract 1. Parentheses plus 1.5. Graph it.
Wait, do we put the 2 in again underneath?
Mr. Davis, you need to change the 2 to a 3.
What?
Because it's 3 feet. It's a 3-foot keel of a boat, not 2 foot.
Yes. Yes.
Mr. Davis, what's the 1 minute?
Window. Okay. And then, thanks, Mac. Change my other equation to 3. Graph. Okay, there it is. And hey, Zoe, I'm going to show you something real quick because you graphed yours. So to do noon, before I do anything, I want to show Zoe something. Okay, it's graphed, right? So go to trace and go 12. Right, trace 12, enter.
6.9.
6.09.
I mean 6.9.
That's what I got also, isn't it? Isn't that what I also got?
We got 6.
I rounded it. Around 6.1, 0.61, 0.61. Okay, now, let's figure out when should we get our boat out? Well, better have your boat out in this time here, otherwise we're in trouble, right?
Wait, we can see.
Oh, sorry. Better get your boat out in this region here, okay? So I might do my intersect. Calculate my intersect. There we go, and I'll show you again.
Trace,
First curve, no, go to calculate. I'll show you again, Zoe.
so second.
Mm-hmm. So I get about 3.8.
Oh, intercept.
And watch, Zoe.
You know when you're
I rounded, 7, 8.
Wait, no, but where do we put it on the line?
Okay, watch. I'm going to do the other one. Second, calculate. Intersect. Am I going too fast?
No, no, we're good.
Enter. So I'm going to put it right by the point where they intersect at. Back and forth arrow, not up and down. So when I get this close, so where do they intersect? Well, they intersect right about there, don't they? So first curve, enter. Second curve, right about there, enter. Guess. I don't need to guess. So it tells me about 13.7.
13.
Okay? And there's one other spot I better get my boat out of, right? There's one more spot I better get my boat out right about here. So I'm going to go intersect. Second, calculate. Intersect. And I'm saying, okay, well, I want to see where do they intersect here. So I'm going to go to the third point. Enter. Enter. Guess. It's about 19.3. Okay, now let me go to my graph. Okay, I got all those values. Okay, so right about 3.8, right about here. Right about here. 13.7. And another one here. So what is that in terms of time? Okay, now I've lost you for the most part, but hold on. So 6 times 8, 60 times 8, 48, right? So at 3:48 a.m., get your boat out of the water. 7 times 60 is 42. So at 13:42 p.m.,